We have learned how to enable tail call optimization. Now let's take a look at its real-life application. This is the factorial function we created before. It can help us calculate the factorial of any given integer. The factorial of 4 is 24, because 4 by 3 by 2 by 1 is 24. Let's do an analysis of how the function works. When we first pass 4 to the factorial function, its else part will be executed. It will return 4 multiple the factorial function. The argument value is 4 minus 1, which is 3. Now the factorial function is called again from inside itself. This time the argument value it receives is 3. It will return 3 multiple the factorial function. The argument value is 3 minus 1, which is 2. 2 is still bigger than 1, so the else part will be executed again. This time the argument value is 2 minus 1, which is 1. If we call the factorial function and pass 1 to it, its if part will be executed. So this time we will get return 1. Factorial 3 equals to 3 multiply factorial 2. Factorial 2 equals to 2 multiply factorial 1. And factorial 1 equals to 1. In the end, the system will return 1 by 2 by 3 by 4, which equals to 24. The problem with this design is the factorial function will be pushed into the stack for 4 times before getting popped out. To calculate the factorial of 4, the stack needs to have 4 frames in it at the same time. If we pass a big number to it, like 100,000, this means the stack will have 100,000 frames in it. As a result, the stack will overflow. Next, let's convert the factorial function to enable tail call optimization on it. In total, we have 3 requirements to meet. First, we turn on the strict mode. Then we need to make sure the inner function is called at the very end and gets returned. We have already met this requirement. The last one is the inner function must not rely on the outer one, which means we cannot keep the number multiply part. But passing number minus 1 to the factorial function is fine, because all it ever receives is just a number. So how do we calculate the factorial this time, since we can only return the factorial function itself? The solution is to add a second argument and calculate the factorial value using it. We name the second argument total. If the value of the first argument is 1, we do not return 1, we return total. Then in the returned factorial function, we set the second argument value to number multiply total. Now the conversion is done. Let's do an analysis of how it works. To calculate the factorial of 4 using the new function, we need to pass 2 arguments to it. The first one is 4, and the second one is 1. The else part will be executed and will return us a new factorial function whose 2 arguments are 4 minus 1, and 4 multiply total's initial value, which is 1. This means we call the factorial function again and pass 3 and 4 to it. As a result, another factorial function will be returned. The argument values it receives are 3 minus 1 and 3 multiply 4. This means we call the factorial function and pass 2 and 12 to it. The returned factorial function will receive 2 minus 1 and 2 multiply 12. At the 4th round, the first argument value has become 1, and the second one has become 24. This means the if part will be executed, and as a result, the second argument will be returned. We will get 24, which is the correct factorial value of 4. Now let's run the new function in Safari. We pass 4 and 1 to it. We got 24. Next, we pass 100,000 and 1 to it. This time we got infinity because the factorial of 100,000 is too big to calculate. But unlike what happened in Chrome, the stack did not overflow in Safari. Tail call optimization makes sure that the stack only has one frame at a time. The new factorial function we just showed you is very common among job interviews. Make sure you understand and, most importantly, memorize it.